All right, kiddos, this is your last opportunity to review dimensional analysis before we apply it to stoichiometry. I want to remind you that you should be taking Cornell notes. Here's a few examples. I just got these off of the internet, so you can look at these if you want to. These are examples of Cornell notes from science students. Make sure that you're leaving room in the left-hand margin to write quiz questions, self-quiz questions, key terms, and that you are summarizing at the end what your notes were about. Pictures are also very helpful. You may not think so at this point, but it will help you remember, especially when a few weeks go by and you were trying to remember what we did. That is the best thing to do. And remember also that we are looking for you to show us your work. If you do not show your work, then we are not going to give you full credit, because we need to see it worked out. In dimensional analysis in particular, it's very important to show your work, because there is so much going on that we don't just magically appear with the correct unit in our answer. There is a logical development that occurs. So if you don't have these written down, because this is last semester's notes, pause the video, write these down. These are the general steps that we're going to be using. And most of us have already been practicing. We write all numbers as fractions. We write everything with its unit. Some of us more so than others. But we should all be writing everything with its unit. Those units help us arrange the conversion factors so that we can cancel out the units that are repeated. Remember that everything that's on top gets multiplied and everything that's on the bottom gets divided. And just to give you a general structure, after you've copied those down, is this right here, which is what we have been doing. And I love this example because this is a one-step problem right here. This is if you're just converting from one unit to another. But if we're dealing with the mole, especially the mole in stoichiometry, what you're going to see is this is going to be the mole part right here, and then there's always going to be something else that they ask you for. So the mole usually is not going to be your final unit. Starting unit, copy it down. It cancels this intermediate unit, which is going to help us get to our final unit, but we don't want it in the final answer, so we have to cancel it. There's your final unit. Okay, so we've got to be able to show all of that work. If you are in Ms. Prado's class, then you have the benefit of having, for dimensional analysis, this little green sheet glued into your journal. If you don't have this, I recommend that you copy it down. I know it's very similar to the other basic rules from the guys that we watched last semester and took our notes on. But this is going to be more structured and helpful. It is doing the same thing. It's a little bit more detailed. So what we're going to do is draw a grid. We're going to put what is given in the upper left corner of that grid right here with the unit. We're going to copy the unit diagonally. We're going to put the label of what we're converting to in the upper right corner. So I'm going through this fairly quickly. Actually, I should probably slow down. But what you should be doing is you should be checking these off after each step. Fill in your equivalent numerical relationship only after you have your 2 units down. That's what's going to help you determine what number goes where. There is a rhyme and reason to it. It's not just wherever it looks good or wherever you want to put your numbers. Multiply everything above the line, divide by everything below, cancel repeated units, be sure your answer has a unit. So let's do this. I wanted to show you here, this is a website from Texas A&M. I wanted to show you that even in college, they expect you to be able to do this. And if you can't do these basic math skills, then they're going to put you in a remedial college class so that you can get caught up on those skills. And you're going to have to pay for that. So learn how to do it now, free. It is easy, and you just have to practice it and it'll be fine. Okay, so they give us a basic example of 1 inch equals 2.54 centimeters. That is a numerically equivalent relationship. So what that means is that I can use that in one of 2 ways. I can use that with my unit of inch on top, if I'm trying to cancel out centimeters from something, or if I'm trying to cancel out the unit of inches, then I would have the inch on bottom. So the unit you're trying to get rid of goes on the bottom, and that's what tells you where your numbers go. So that's why the units are so important. First example, and yes, they work it out for us, and I'm going to show you the way that you're going to want to work it out for us in class. So how many centimeters are in 6.00 inches? Ooh, 6.00. That's, let's see, 1, 2, 3 significant figures. So my answer has to be in 3 significant figures. So let me follow my steps here. I'm going to put my 6.00 inches right there. And first step, draw a grid. Done. Second step, put what is given in the upper corner. 6.00, no naked numbers, it's an inch. 3, copy the unit diagonally. Unit, not the number, just the unit gets copied diagonally. Next, put the label of what you want to go to at the top. We want to go 2 centimeters, that's what they asked for. Now fill in my relationship. So if I look at my relationship, it's 1 inch, 2.54 centimeters. So wherever inch is, I'm going to put the number 1. I can't put the 2.54 there because that is what goes in front of centimeters. So that's how your units tell you what numbers go where. Now I can multiply across the top, divide by what's on the bottom, cancel repeated units. Inches repeats on the top and the bottom. So they cancel out. The answer here, it comes out to plug it into your calculator. Always remember to plug these into your calculator. I get 15.24 centimeters, but we are rounding it to 3 significant figures, and so that's why they have their answer already at 15.2. Right, if we're going to do the same thing, converting the other way, our given is 2.24 centimeters. I would just draw a grid. I'm just going to use that example there. 24 centimeters goes on top. I would write centimeters on the bottom, inches on the top, and those units would be what tells me that 2.54 goes on the bottom and 1 goes on the top. When you plug that in, this comes out to about 9.4488, But again, they gave us 3 significant figures, so we'll stop at 1, 2, there's my third figure, there's an 8 behind it. That's why it's 9.45 inches. That's the answer. Okay, so those are easy steps. Those are easy setups. What we really need to look at are multiple setups. And we did something similar to this here, where it's showing us a conversion. Okay, showing us a conversion from years to seconds. Right? How many seconds are in 2 years? So we do the setup, and it's the exact same thing. We start off, we know this is going to be a big one because we don't have a conversion that goes directly from years to seconds. So that means that we're going to have some intermediate steps. Make our known into a fraction by putting it over 1. Our first conversion factor, there we go, breaks down years. Then we have days, minutes, hours. Okay, multiply across the top, divide by what's on the bottom, and you do get this. I want to get to some good chemistry stuff. That's why I'm kind of rushing through this here. But if you don't have this metric system written down in your journal for this semester, write it down because you need these. And we had them in the first semester notebook, but if you don't have them now, you need to get them down. So pause the video, copy them down. You need the prefix, the abbreviation, the meaning, and an example. All of it. Okay, so let's do this one here. I kind of wrote over it. 50 milliliters to liters. That's what they want us to convert. 50 milliliters to liters. So I always start by, let's draw my grid, 50.0 milliliters. That's actually 3 significant figures there as well. What's the next step? Check it. What's the next step? Copy the unit. Write what I want on the top. Put in a numerically equivalent relationship. Right, well, if I'm looking at milli, Milli means it's 1,000th of the base unit. And there's a couple different ways that you could do this. I would always just put 1 milli. And what does milli mean? Milli means 10 to the negative third, right? It says so right there. And then just multiply across the top, divide by the bottom. Well, you could also, if you can remember that there's a difference of 1,000 between the two, you can also just make it where you divide it by 1,000 milliliters. Milli is a very small unit, so you're going to need a lot of it to equal 1 liter. And so that's why this is 1,000. It's 10 to the third instead of 10 to the negative third. We talked about that when we did dimensional analysis. It doesn't matter which way you want to do it, just make sure that it is a numerically equivalent relationship. When you work this out, when you plug that in your calculator, you'll still get the same answer, 0.0500 liters. Okay, I want to do another one. I'm going to skip over density here because I want to get to one that has an equation that needs to be balanced right here. Ta-da! We'll have quiz questions here. All right, so this is really what you're going to be doing. This is what you will be doing in stoichiometry. So you're going to have a balanced equation. You may have to balance it. It may be given to you, but you have to have a balanced equation. And the way that we're going to set up these problems is you are going to start with what they give you. They still give us a known, which is right here, 45 grams. So that's what I'm going to start my calculation with. We put it over 1. And I know I'm going to multiply by some conversion factor or set of conversion factors over here. Okay. They tell us, they give us molar mass. They want to know how many atoms. And they tell us the molar mass. But you could do that on your own if you needed to. Anytime you want to convert away from grams, look in your hearts. You're going to copy that unit of grams at the bottom. You're going to put mole on top. Molar mass is 1 mole over the grams from the periodic table, and they already told us that's 17. Cancel out your units. When you do that, you will be left with the unit of mole, which is not what they wanted. They wanted atoms. So that's what tells us we have to go another step. So continue that fraction. We're going to copy that unit of mole to the bottom. They want atoms, which is a part of a particle, a type of particle. Right? If you look in your hearts, atoms is on that section with particles. So if you look at the example for that, it is for every mole, 6.02 times 10 to the 23rd particles. And H3 happens to be a molecule, so it's molecules. We are almost there. They wanted atoms. And this is where some of you get tripped up a little bit, but it's okay. Remember that you just follow the same procedure. You have particles here, which are molecules. That's the type of particle. That's not what we want in our answer. We want atoms. So you're going to copy it down diagonally to get rid of it. We can find a relationship between the number of atoms that are in a molecule. If we look at NH3, they actually have a typo there. That should be 4 atoms. Oh, no, I'm sorry. It's just hydrogen. That's what they're looking at. Sorry. That's why. They're just looking at hydrogen. If they want to know how many atoms total, it would be 4 because there's 1 nitrogen and then the 3 hydrogen. But they're just asking for hydrogen. I didn't read the problem right. And when you plug that in your calculator, multiply everything across the top, divide by each number that's on the bottom, and you should get this answer right here. Okay? All right, so what I need for you to do is I need for you to do these quiz questions right here. And I need for you to show me your work. And actually I'm gonna take one out for you. No question 2, just because we're not dealing with density. I do want you to be able to do question 1 and question 3. How's that? And that is what I will check. I will check question 1 and question 3 in class. So let's do that. Happy homeworking. I'll see you in class.